Hey everyone, Andy here with the Onehouse team. Today we're going to talk about the precombine key in Apache Hudi. The precombine key is one of the great features of Apache Hudi. It serves as the source of truth to help you resolve duplicates that are coming into a table. One example that's common here is in IoT devices. Imagine you have devices like drones that are constantly capturing telemetry and tracking the latest state of the world. Here, they might measure things like temperature, how much water they've delivered to the plants, or any other telemetry that you want to get. The thing about this is you might have some unreliability in the physical devices that are sending that data. Let's say, for example, a drone goes out of range for service. All of the sudden, it might send a batch of 30 minutes worth of data that all needs to be processed at once. That's where the pre-combined key can come in handy. It allows you to know what is actually the latest piece of data in that stream. Let's take a look at an example here. In this example, I'm looking at a ride share table. This is a pretty standard table. We have a record key, which serves as our primary key in Hudi, the UUID, that's right here. And then we have our pre-combined key column, the timestamp column, which is being created actually in the source. And this will tell us when we have multiple records coming in at the same time, how do we deduplicate? Well, we can use whichever has the larger timestamp. Now, if we look at a real example here, I can look at an input batch of data. So in this case, let's say the driver's phone is capturing data, or you have some microservices that's a microservice that's sending data to Hudi. You might have multiple records coming in at the same time in a single batch of data. So here we see two records that have the same UUID, 123. So this is the same trip, but they do have different metrics. The first one, the fare is $5. So what might happen here is originally the fare is $5, but due to some traffic or going through an unexpected toll, the fare has to increase to $7. Now, maybe the service that's sending these is delayed, so they both come in the same input batch. The Hudi table needs to know which one to write. We look at the pre-combined key here, which we saw as the timestamp. So we can see here, the first one is a timestamp of 1, second is a timestamp of 2. So what we can do is just get rid of that first record in the batch. And when we write to the actual table, we will commit only the second record with the timestamp of 2 and the fare of $7. Now we can look at some sample code for creating this in the table. The pre-combined key is really simple. It just goes into those table properties. I'll highlight it here. So if I look at my table properties, I can set the pre-combined key field as timestamp right where I set my primary key or record key as the UUID. If I'm doing this in Scala for some Spark code, I can set this in my options very similarly, and I will just set my pre-combined key field here in my Hudi write configs. Okay. Now that's all pretty simple. And one more thing that's important to know with the precombined key is you can also configure how the precombined key gets used. So by default, it's used for data that's coming in the same batch, but you can actually set some configs for the table to manipulate that if you have different use cases. And I'll show an example there as a slightly more advanced feature that you can use in Hudi. Payload classes allow you to control how data is written into the table when you have data coming in across different commits or different batches. The example I gave before is around when you have data that's being written into Hudi in the same batch, but what if you want to handle duplicates that are coming in across different batches? The default in a table is that you will just overwrite the data with the latest batch. But there might be cases where you have data coming from different places and it might come out of order. For example, if it's coming from IoT devices that have different internet connectivity, or you have different microservices where certain services might be down and send their data later than the others. We can look at an example here with multiple commits, and we can look at the different configurations that you can set and how they will affect the table. The first commit here, we can see record key is A, the precombine is 20 with a value of 1. Now imagine another commit comes into the table, and the second commit comes in with the same record key, a lower precombine key, and then a different value. There are two ways that we can handle this. First is with the overwrite with latest Afro payload, and this is the default behavior for Spark. So this is what will be set by default. What this will do is kind of what you'd expect in a normal table. It'll take the latest commit and it'll just use that value. So for our record A, we'll have 2 if this is the config that's set. Another option is to use the default Hudi record payload. And I know it says default, but this one's actually not the default for Spark. The overwrite is the default for Spark. But if we look at this, what this will do is it'll actually compare the precombined key for every batch of data that comes in. So first, when commit 1 comes in, it'll set the value to 1. And then when commit 2 comes in, instead of naively writing commit two's value under record key A, it will actually compare the precombines. And since commit's precombined key value is higher at 20 compared to 10 for commit 2, it'll continue to use commit 1's value, which is 1. Now you can set this similarly in the table configurations, and you can see here that in my Scala example, I've just added this write payload class. So this gives you a bit more flexibility for how you handle late arriving data with the precombined key. Now I'll show you how you can easily create a flow to build your Apache Hudi table in Onehouse and set a precombined key. Here I can create a new flow, which allows me to ingest data from a source and write it to a table in Onehouse. I can choose a source. Let's choose a Kafka topic here. We'll make this a mutable table so I can write updates to the table. And now I can select from any topic in my Kafka source to create an Apache Hudi table. Let's grab this clickstream topic. I can see the data schema. I can set quarantine for some data validation, add transformations. But what I'm really interested in is setting my precombined key field. In the Onehouse UI, I can easily preview my schema for the table. And this is a small one, but you could imagine you'd have a larger schema with a timestamp. I'll just select properties as my precombined key field here. And I simply select location to store the table, select some catalogs to sync to, and some compute. And then when I create the flow, it'll create the table for me with that precombined key field.